Hi everybody, I am going to teach you today how to calculate potential energy. So first things I'm going to do is I'm going to show you how you're going to create your notes for today. So first off, we're going to go ahead and title these potential energy. And your paper can look exactly like mine today. The first thing that I want to do is I want to write out what potential energy is. Now, if you remember from your last two lessons, you remember that potential energy is the energy of position or stored energy. So for example, if we have a car traveling up a hill, when that car comes to a stop up at the top of the hill here, before it goes down and is stopped, our car has what we call potential energy. And I'm going to label that as PE. Okay? Our potential energy can change depending on how high this car is on top of the hill. So for for example, if our hill was a little bit taller, we might have more potential energy as we were to race down the hill. You can think of it as like riding your bike down a hill. Do you have more energy when you are on a shorter hill, or do you go faster and have more energy when you're on a higher hill? So there are two ways to calculate potential energy. So I'm going to separate my paper down the middle here, and I'm going to focus on my first side. Our first formula that we have is potential energy equals mgh. Now, I'm going to go ahead and label what these different letters stand for. So my m is equal to my mass. My g is equal to gravity. And my h is equal to height. Now, when I solve using this formula, my gravity for these purposes is always going to equal 9.8. And I always want to make sure that I put my units on there. Okay? 9.8 meters per second. My mass is going to be any number in a problem that is measured in grams, which is G, kilograms, which is kg, anything besides pounds. And then finally, my height may be measured in meters, maybe millimeters, or kilometers. But these are going to be your key words when you pull out your measurements from a problem. Let me go ahead and put their units here. I've got meters, I've got millimeters, and I've got kilometers. Perfect. Now, the other formula that we can use is PE, potential energy, equals WH. Now, we know from solving over here that our H is equal to height. And this W is actually going to equal weight. However, weight is not measured in the typical pounds that we use. For example, when you go into a grocery store and stand on that scale at the front, right? Our weight is going to be measured in newtons, which is usually indicated by a capital N. Now, again, our height usually measured in meters, millimeters, or kilometers. In the next video, I'm going to show you 2 examples of how to solve these different problems.